Welcome back to the course of operating system. In this session, we are going to discuss about the CPU scheduling algorithms, starting with the first algorithm, which is first come, first serve. So what are the CPU scheduling algorithms? The function of the CPU scheduling algorithm is to select one process out of n processes residing in the ready queue. So we learned that there can be n number of processes loaded in the memory, and which we call those all processes are in the ready state. And we know that in the running state, only one process can be in the execution. So OS needs to have some decision making algorithms which picks up one of the process from ready state and give it to the dispatcher, and dispatcher schedules this process to the CPU. So while doing this selection of the process, OS keeps this goal in mind. The first goal is to maximize the CPU utilization. In other words, while doing the selection of these processes, OS should make the best use of the CPU and not keep the CPU idle even if there is some process waiting in the ready state. At the same time, OS also needs to minimize the waiting time of every process and minimize the response time also. What is meaning of this waiting time and response time is, let's say if you go to any ticket window or stand in any queue. So the first thing comes to your mind is your chance should get in minimum time. In other words, your waiting time should be as less as possible. Same goal is applied here also. Means when a process is waiting in the ready state, ready queue, OS should design the algorithm in such a way that the waiting time for every process should be as less as possible. And other goal is to minimize the response time. The meaning of the response time is the time from which a process arrives in the system and the time at which it is scheduled to CPU first. Means let's assume that the process arrives at 1 o'clock and it is scheduled to CPU first time at 2 o'clock. Then 1 hour is the response time for that process. Meaning is that the process starts producing the output after 1 hour. So 1 hour is the response time of that process. The third goal is no starvation. The meaning of the starvation is, if the process is waiting in the ready queue, then it should know when its chance will come in the CPU for execution. To give the analogy, let's assume that you are standing in some queue at the ticket window and some senior citizen people arrive. Now you allow those senior citizens to get the ticket. In that case, I can say that the people standing in the queue get starved, because if senior citizen people keeps on coming, then the waiting time of those people standing in the queue will increase. That's how those people gets starved. Here also in the operating system, any process that is waiting in the ready queue should know when its chance will come in the CPU. Means it should not wait for long duration of time in the ready queue to get its chance. The fourth goal is maximize the throughput. The definition of the throughput is number of processes completed per unit time. So here is the simple formula for throughput. In the numerator, number of processes, and in the denominator, total time taken by all processes to complete. To give the analogy, let's assume that you go to some event which starts at 10 a.m. and the event completes at 3 p.m. let's assume. So the total duration of the event is 5 hours, and in that 5 hours 100 people arrived and get served for whatever purpose they are arriving for the event. Now I can say that in 1 hour at that event 20 people get served. So I can say that the throughput of that system or event is 20 people per hour. So before we jump into any CPU scheduling algorithm, let's discuss about some terminologies that all CPU scheduling algorithms are going to use. So let's discuss various process times based on which we are going to do all calculations later. Consider there are n processes in the operating system. The first term is called as arrival time, AT, of each process. So here arrival time of process Pi, let's assume that it is denoted by AI. So arrival time is nothing but the time at which a particular process arrives in the system. The second factor is called as burst time of process Pi, denoted by Xi, let's assume. The definition of the burst time is the duration of time required by the process for execution, means how much time it will take in the CPU to execute its instructions. The third factor is called as completion time. So when a process terminates or user kills a process, let's assume, that time is called as completion time of the process. The fourth term here is the input-output burst time, IOBT, of process Pi. Let's denote it by YI. It is nothing but the duration of time taken by a process in the IO device, means to do the IO. Turnaround time. So this factor, which is turnaround time, is based on previous basic factors that we just talked about. So turnaround time is nothing but the total time spent by any process in the system, right from its arrival to its departure, means its completion. So the simple formula is completion time minus arrival time, which gives us the total time spent by the system, by the process in the system. And obviously the average is given by 1 by n summation of all the turnaround times of all processes. To just give the analogy, I can say that when you go to any event or any function, the time at which you arrive at the event, let's say you arrive at the event at 1 o'clock, 1 p.m. and you leave the function or the function premises at 4 p.m. So you have spent 3 hours of time there. So 3 hours is nothing but the turnaround time of the person. The second factor is called as waiting time of the process. Before I jump to the definition, let me give the analogy. Again, let's say if you go to any function and you arrive at the function at 1 o'clock and you stand in the queue of food, let's say, to get some food, and you take 10 minutes to get your chance to get the food. So 10 minutes is your waiting time, and after 10 minutes you take the food and start eating, means you do your task. So here waiting time is nothing but the total time spent by the process waiting in some queues of operating system. And the simple formula here again is given by the total time spent by the process, that is turnaround time of a process, minus how much time it took in the CPU and how much time it took to do the IO. Remember that burst time and IO burst time are not waiting time. They are the actual duration of times for which the process is doing some task, and rest of the time it has spent in the system is nothing but the waiting time of the process. And again, the average waiting time is given by 1 by n summation of all waiting times of processes. The third factor here again is called as schedule length, denoted by capital L. The definition of the schedule length is the total time required to complete all processes in the system. Means when the last process leaves the system, means maximum of completion time of any process, minus when the first process arrives in the system, which is nothing but the minimum time, minimum of arrival time of any process. Again, let's take the analogy of some event at which the first person arriving is at 10 o'clock in the morning, and the last person which leaves the event is 5 o'clock in the evening. So total 7 hours becomes the schedule length of the system here. The fourth factor is called as throughput. The definition of the throughput we have seen. Numerically we can say that n number of processes can be completed in L time. That's why the formula is n by L. Let me just give the analogy once again. So let's say in 5 hours, 5 is the schedule length. In 5 hours, let's say 100 people came to the event and served for any purpose. So I can say that in 1 hour, the system has served 20 persons. So that's why I can say that the throughput of the event is 20 persons per hour. CPU scheduling algorithms are of two types: preemptive scheduling algorithms and non-preemptive scheduling algorithms. The meaning of the preemptive scheduling algorithm is when a process execution is started, after the execution of process is started, it can be halted even if the process burst time is not completed. Means we can forcefully halt the execution of the running process. Those algorithms are called as preemptive CPU scheduling algorithms. Whereas the non-preemptive scheduling algorithms, once a process is scheduled to CPU, its execution cannot be halted in any case by the operating system. So the CPU, the decision to leave the CPU will be purely made by that running process only. And it will leave the CPU only when its burst time is completed. So based on these two categories, let's start our discussion with the first algorithm of CPU scheduling algorithms, which is first come, first serve. The criteria on the basis of which we decide which process will be scheduled to CPU next is the arrival time of the process. So according to the increasing order of their arrival times, we will decide, the OS is going to decide the sequence in which the processes are going to get the CPU for execution. And the mode means whether this algorithm behaves in a preemptive manner or non-preemptive manner. Here the FCFS by default behaves in a non-preemptive manner, meaning is that once a process is scheduled, OS cannot halt the execution of that process forcefully. So let me explain this with the help of an example. Let's take 6 processes here. Arrival times of these processes are given. Let's assume that P1 arrives at time 0, P2 also arrives at time 0, and so on. The burst time of process is, P1's burst time is 2, means it will take 2 units of time in the CPU for execution. P2 will take 3 units, and so on. And the question is, calculate the average waiting time, average turnaround time, schedule length, and the throughput of the system. So try to solve this question and come up with this answer. I'll explain the solution. So when 2 or more processes arrival time is same, you can consider the process number. So here, for example, 0 and 0 is the arrival time of P1 and P2. So I will simply go with P1 first, followed by P2. That's the meaning of this note here. Let's look at the solution. So the solution is to draw the Gantt chart, which is the timing of the CPU basically. So for all algorithms, we are going to follow the Gantt chart method to solve to get this average turnaround time, average waiting time, etc. So Gantt chart is nothing but the CPU timeline. So let me demonstrate it with the help of this CPU timeline here. I have taken this CPU timeline starting with 0. So let's assume that at time t is equal to 0 I have marked here. So I am going to mark the arrival of processes below this timeline, and I am going to mark the completion of processes above the timeline. So let's start the execution. At time t is equal to 0, process P1 and P2 arrives. At this time, I want to make a decision which process will be scheduled in the CPU. So the answer is very clear. We will look at the arrival time of these processes, and there is a conflict between the arrival time. So we will first give the chance to P1 now. So I have scheduled the P1 in the CPU. I know that it's a non-preemptive algorithm. That's why once the process is scheduled to CPU, it will take its entire burst time, which is 2 here. So 0 plus 2 becomes 2, and at time t is equal to 2, that process is going to complete. While it is doing its execution, at time t is equal to 1, process P3 is arriving in the system. So remember that if someone is under execution, is executing, is in the running state, someone may arrive in the ready state. So that's where here is the P3 which has made the transition from new to ready state, while the P1 is execution. At time t is equal to 2 also, process P4 is arriving, and at time t is equal to 2, the process P1 is getting completed. At time t is equal to 2, we have to again decide out of P2, P3 and P4, because P1 is completed. So P2, P3 and P4, which one will be scheduled? So let's look at the arrival time of P2, P3 and P4. So obviously P2 has come first, which is 0. That's why I have scheduled the process P2 up to t is equal to 5, because its burst time is 3. That's why 2 plus 3 is equal to 5 here. While it is executing, at time t is equal to 3, process P5 arrives. At time t is equal to 5, process P2 completes here. And at time t is equal to 5, I want to again make the decision which process will be scheduled. So P1 and P2 are completed. Now it is chance for P3, because among these P3, P4, P5, P3 has arrived first. So I am scheduling the process P3 here. P3 is going to take 1 unit of CPU, that is burst time. So that's why at time t is equal to 6, P3 is going to be completed. At time t is equal to 6, again I am going to schedule P4, which is the next according to the arrival time. And it will take 4 units of time in the CPU. And 6 plus 4, that is at time t is equal to 10, it is going to complete. And while it is doing the execution, at time t is equal to 8, here is the at time t is equal to 8, process P6 is arriving. So at time t is equal to 10, P4 will complete, and at time t is equal to 10, we have to make a decision which process will schedule next. So the next one is after P4, P5 has arrived. So I have scheduled P5 here, whose burst time is 6. So 10 plus 6, it is going to be the 16. At time t is equal to 16, P5 completes. And one last process is remaining, that is P6. So when there is only one process in the CPU, in the entire system, you can directly schedule that without applying any decision making factors. So 16 plus 7, that is 23. So at time t is equal to 23, process P6 completes here. And this completes the Gantt chart for this particular example. So with this Gantt chart, let's calculate all the factors now. So to calculate all the factors such as average turnaround time, waiting time, etc., we have to first calculate first mark the completion time of all processes. So let's look at the completion time. So as per the Gantt chart, P1 is getting completed at time t is equal to 2, P2 is getting completed at 5, P3 is completed at 6, and so on. So I am marking the completion time in the table 2, 5, 6. 10, 69, 23. With the completion time, I can calculate the turnaround time now. The formula for turnaround time is completion time minus arrival time. So 2 minus 0 will be 2, 5 minus 0 will be 5, and so on. So let me just show here 2, 5, 6, 5, 8, 13 and 15. How come it is 15? Let's check. 23 minus 8, which is nothing but 15. Just add all the turnaround times, the total is 48, and obviously 48 divided by 6, the average is 8 time units. Similarly, I can calculate waiting time. Waiting time's formula is turnaround time, that is total time spent by the processing system, and out of which how much it has waited. So we just subtract the burst time from the turnaround time, and remaining time is nothing but the waiting time. So here the waiting time of process P1 is 0 because 2 minus 2, that is burst time, 0. 5 minus 3, which is 2. 5 minus 1, that is 4, and so on. So the total is 25 and the average is given by 4.17. So that's how we get the average turnaround time and average waiting time. Let's calculate rest of the factors. The third factor is schedule length. The formula is given by completion time of last process, which is 23 here, minus arrival time of the first process, which is 0 here. So 23 minus 0 indicates the 23 is the total time required to complete all processes in the system. The next factor is throughput. Throughput is given by N by L. L is schedule length. So there are 6 processes divided by 23 is the total time required to complete all processes. And the fraction is given by 0.26. So that's how we reach to the end of this topic, CPU scheduling algorithm, which is first come first serve. In the next session, we are going to take more examples of FCFS. Thank you for attending this session. See you in the next session.